Hi, I'm Sara, PhD in computer engineering. My research is about group-based personalization using topical user profile. In this talk, I'd like to start with an introduction to personalization and especially personalization using user profile. Personalization using user profile is investigated in lots of research in recent years. Personalization is the task of re-ranking the retrieved document set concerning the user profile. Actually, personalization uses re-ranking algorithms to improve the return result by search engine. Although user profile are indicative of the user interest, but they have the limitation for new users or users without any history, and in more times it's needed to use a group of user profile to re-rank the return result by search engine. A cluster of users in the form of a group profile can be used as a solution to the sparsity problem. One of the disadvantages of the personalization-based user profile is that it is built by considering only the documents that the user has clicked. The set of the clicked documents might be sparse for some user. To overcome the problem, in this research, we present a group-based personalization model using topical user profile and comparing the result of the proposed ranking methods based on the group and user profile. To cluster the groups of users, we use the Cummins clustering algorithm, and the similarity between users is measured by the symmetric Kullback-Leibler divergence between their latent topic distribution. In the issues related to privacy concern, group profiles are also more secure than user profile because both the computation and the storage of the user information are done as a group of users. So let's have a look at the user profiling model. In this model, we have users and the click document for user. Using these documents, we have tried to create topical user profile. We've used LDL latent rich allocation model to create topical user profile. And the probability of the topic for the given document is obtained from LDL topic model directly. To measure the similarity between users, we need to create user profile. The user topical profile of a user is defined as a vector of the obtained topics of the LDR model on the click document as probability of user given topic Z. We can find the similarity between user from symmetric between any pairs of user from symmetric Kullback-Leibler divergence between their latent topic distribution as in equation 1. The Kullback-Leibler divergence between their latent topic distribution can be measured using equation 3 and 4. As the Kyle is not symmetric algorithms, we measure the sum between Kyles. This transformation ensures that we get a similarity value within the interval 0 and 1. Actually, user profiles are incomplete for new or unseen users. To resolve the data sparsity, the history of similar user can be grouped and used for personalization. In continue, we present a group-based personalization by changing in the re-ranking algorithm for user profiles. As previously mentioned, a user topical profile is modeled by the set of documents which the user click on. Then users are clustered using the similarity between their topic probability distribution or probability Z given user. A Cummins clustering algorithm is used to partition the user to C groups, and the number of clusters is parameters, and C is the cluster of user U. We model the group-based personalization in equation 5 and 6. In this equation, the ranking score probability a given query and CU is produced using probability of document, probability of words in query, and topics in document. Equation 6 generalize the user ranking to the cluster of user, resolving the sparsity problem. The probability of CU given Z is estimated using equation 7, and the lambda parameter weights the effect of group profiles on ranking process, and group profiles are computed as follows. Similar to conducted work in 25, an exponentially decaying function is used in the user profile to give more weight to recently clicked document. Considering CU equal 1, this equation could be calculated for a group of users. And in the evaluation part, the first we discuss about dataset. For the experiment, OL track 2030 session track and 2040 session track of web search engine logs are used. OL query log contains 3 months query log in 2026 is used in this research, and we cleaned the dataset by only retaining queries which resulted in a click on a URL. In other part of research, we use the session track consists of query sessions for different topics along with the click document and user ID. To evaluate the personalization using group profiles, we divided dataset into 95% for training and the last 5% of queries for testing. The personalization metrics are success at rank K, S at K, the mean reciprocal rank MRR up to rank 10, and normalized discounted cumulative gain. The number of topics used for LDI is an important parameter. The relationship between MRR and this parameter is investigated in a small development. The result indicates that using 40, 30, and 30 topics yields the best result in OL session track 2030 and session track 2040. To investigate the relationship between the number of clusters and MRR, different number of clusters are evaluated. And as shown in figure 2, the best result is obtained with K30, K20, and K20 for OL and session track dataset. To test our hypothesis that group profiles resolve the sparsity problem, we compare the personalization effectiveness of user and group-based ranking method. 3 ranking methods are used in our evaluation: generic ranking without personalization, user profile-based personalization, and group profile-based personalization. To compare the personalization method with baseline method with no personalization, we use TF-IDF and BM25 BM25 as baseline models, and to calculate the baseline, we rank each result using the TF-IDF and BM25 scoring as long term with no user profile. Table 1, 2, and 3 report the MRR S@1 and S@10 scores for the 4 methods: TF-IDF, BM25 personalized, 25 personalized topic model using the user that we call here UTN, user topic model, and personalized topic model using a group of users called GTM, group topic model here in OL session track dataset. In all tables, the first and second rows represent the ranking scores when using the TF-IDF and BM25 method. The third method is related to the personalized ranking model using user profile. Finally, the last method shows the result when all queries are re-ranked using group-based profile. In all tables, we experimented the result for short, session, and long term. Short term is included one data of 1 month, while session is for one session, and line is consists of all data. As shown in table 1, 2, 2 and 3, the ranking results of TF-IDF and DM25 with no personalization are less than the other personalization method. When we consider the result of group-based personalization using the GTM model, it is evidence that it achieves a higher score for all short, session, and long-term profile in all datasets. This indicates that using group-based personalization is a better strategy than using user-based personalization in all short, session, and long-term. Also, the short-term profiles show higher MRR than session and long-term profile in all datasets. For further research, we investigated two models, UTM and GTM, using NDCG metric in track datasets, using provided judgment in these datasets. Figure 3 and 4 show the NDCG at 10 base performance comparison for the two personalization using user and group in session track dataset. As can be observed, using group profile improve NDCG at 10 by an average of 4% in two datasets when using long-term user profile, while short-term and session-term user profile are improved by 5% and 6% accordingly. So, using group profile instead of user profile improves all cases. As expected, the short-term user profile is more effective than the others. As a conclusion, in this article, a new group-based personalization using topical user profile is proposed for a sparsity problem in personalization of new or without history users. Our proposed model for personalization is defined in terms of the latent topic models for group of users rather than relying solely on the user history directly. And the results show the improvements about 7 and 6% in short and long-term profiles. Thank you for your attention, and if you have any question, please feel free to contact me.